One of the most frustrating parts of 3D printing. You spend hours designing a part in Fusion 360, hit print, and the screw just doesn't fit. The threads jam, and the whole assembly is a bust. But what if I told you there are a few simple tricks to guarantee a perfect fit every single time? In this video, I'll show you the essential techniques to master 3D printed threads, we'll build a bolt and nut from scratch, and I'll show you the exact steps that separate a failed print from a perfect one. Let's get started. First, let's design a functional M16 bolt. I'll start with a 16mm diameter cylinder for the shaft and add a hexagonal head, just for aesthetics. Now, we can use the thread tool on the cylinder. Fusion automatically detects the M16 size. Fusion has presets for many different types of threads. For this demonstration, simply leave it as the default isometric profile. We just need to ensure that modeled is checked, click OK, and then we have a printable bolt. So we have our bolt. If we design a nut with the exact same M16 dimensions, will it fit? No. This is because of tolerance. Your 3D printer isn't perfect. A 16mm part might print at 16.1mm, and a 16mm hole might print at 15.9. When the bolt is bigger, the nut is smaller, they won't fit. The solution is designing a clearance, an intentional gap. For most printers, a gap is between 0.2 and 0.4mm. This is a great starting point that will work for most printers. Let's design a nut with a 16mm hole and apply a modeled thread. Fusion automatically remembers the size that we made our bolt, so there should be no need to go back and change the settings to make sure they match. Now, let's add our clearance. We can use the Press Pull tool. You can find it in the Modify tab, or press Q to open it. On the bolt, I'll select the thread faces and apply a negative offset of minus 0.1mm to make it smaller. On the nut, I'll select the internal threads and apply a positive offset of 0.1mm, making the hole bigger. This gives us the total clearance of 0.2mm, which is often enough to account for the printer inaccuracies and allow the parts to thread together smoothly. So now it's time to test. I input the model we just designed into the slicer and hit print. And unsurprisingly, the threads fit perfectly. I would always recommend testing first, especially if you're going to be printing a large assembly. So let's recap the workflow for perfect threads. First, design your parts, and if you want, add a chamfer for a lead-in. Second, use the thread tool, and always make sure to check the model box. Third, use the offset face tool to apply that clearance to your threads. And finally, test it before printing. You see, designing functional 3D printed screws isn't luck, it's engineering. When you understand modeled threads and master tolerances, you can take the guesswork out of it. If you learned something new today, and you're ready to tackle your next project with confidence, hit that like button, and be sure to subscribe for more practical design guides just like this one. Thanks for watching, and I'll see you in the next one.